Hey, my Adams Panthers. Today we are learning about the periodic table and reactivity. So, if you missed today's Zoom lesson, that's what we talked about. So, I'm going to briefly explain how this periodic table works. It goes along with protons, neutrons, and electrons we talked about, as well as your Bohr models. We're going to go straight to what we need to learn about the periodic table because most of this we have already talked about. So, in your journals, you should have in your canvas your periodic table provided by me. I told you guys to make sure you screenshot it, so you should have a screenshot of your periodic table. What I want you to do is we are circling our groups which go up and down vertically, and we're going to label that 1. For our periods that go left and right horizontally, we're going to draw a circle around that and we're going to label it 2. And you are more than welcome to utilize any color you would like, but this is the first thing we need to do to our periodic table. So again, you should have a screenshot and you should be able to mark up. So we're going to pick any group and you're going to circle it and label it 1. Any period that goes from left to right, circle it and label it 2. Alright, from there we're going to discuss what is the purpose of the periodic table, how it works, and what do we use periods and groups for. The periodic table arranges all the known elements in order from increasing atomic number. So from here, as we go throughout the periodic table, you'll notice that the atomic number, which is the number above the chemical symbol, is increasing. Alright, now we're moving on. Since we talked about what the periodic table is about, we're going to discuss periods and groups. Earlier on, I told you guys to make sure you circle one of your groups. You could pick any one of the groups. And remember, groups go up and down, and we labeled that 1. Then you could pick any of the periods. I'm going to pick period 4. Alright, and we're going to label that 2. So that's the periods and groups. So we're going to talk about periods first. So I'm going to erase this. Now, periods on the periodic table go from 1 through 7. So the numbers are on the side here, but they run left to right. So we got period 1, period 2, period 3, period 4, period 5, period 6, and period 7. Now, as you guys are going through the periods, the atomic numbers are going to increase from left to right, as we talked about earlier about the periodic table itself. Everything that's in the same period will have the same number of energy levels or shells. So if you can recall when we did Bohr models, the circles were the energy levels, or they can also be called shells. That's what your period number determines when you're doing a Bohr model. Now, the chemical properties are not similar at all if they're in the same period. So, when you're looking at periods, again, it determines your energy levels or the amount of shells you're going to have when you do a Bohr model. So, for example, anything in period 1 will have 1 energy level. Anything in period 2 will have 2 energy levels. Anything in period 3 will have 3 energy levels. So, for example, if I were to do the Bohr model for, let's say, lithium. Lithium is in period 2. I would draw a picture for my Bohr model. So I'm going to put my protons and neutrons in the nucleus because we know we do that. So I know my atomic number is 3, so that means my protons are 3. If I look at my trusted periodic table for lithium, my atomic number or my mass number is going to be 7. So I'm going to subtract 7 minus 3, and that's going to give me my neutrons, which is 4. So if I have 3 protons, that means I also have 3 electrons. So I'm going to draw 1 energy level because I can only put 2 electrons on the first energy level. And my second energy level is going to have 1. So because lithium was in period 2, it has 2 energy levels. So that's what the periods tell you about Bohr models. Alright, so I'm going to erase this. And then we're going to move on and we're going to talk about groups. circled our group number. Let me erase this, not circle this. I'll do one over here. So we circled our group, and I'll do 14. All right, and we labeled it 1 to let us know that that particular circle for 1 is going to represent our groups. Now, if you didn't notice at the top of your periodic table, you're going to have numbers on top of each one of those groups, and it goes from 1 through 18. Now, what that means for the number on top, meaning the valence electrons. So the electrons that are on the last energy level are called valence electrons. Now, that's determined by your group number. So, for example, if I wanted to know the valence electrons for group 1, it's the number at the top, and it's going to tell you 1. So I know everything in group 1 will have 1 valence electrons. Group 2, 2 valence electrons. Now, the things about groups is their chemical properties are going to be very similar, so they react very, very similar. And now group 1 is going to be the most reactive group, and group 18 is going to be the least reactive group. Now, when you get to the groups that are 13, 14, 15, 16, 17, 18, their valence electrons are going to also be found at the top. So you'll see a number on your periodic table that's going to have 3A, 4A, 5A, 6A, 7A, 8A. That lets you know your valence electrons, because the most valence electrons you can have is 8. Yes, only 8. Even though we have 18 groups, you can only have 8 valence electrons. So make sure you look at that number right below the group number that has an A. That's going to give you an amount of valence electrons. And remember, valence electrons are the electrons found on the last energy level on your Bohr models. So that's what we know by looking at the periodic table. Anytime you have your periods, that's going to tell you how many energy levels you're going to have. Your groups tell you how many valence electrons you're going to have on your last energy level. Okay? So now, we're going to talk real quick about valence electrons and what makes an atom happy. So we're going to get into also some other things we need to write on our periodic table. As you go down, or as the periods increase, your energy and your reactivity will increase. So if you have that periodic table, you're going to draw a line down with the arrow, and you're going to write increasing energy and reactivity. This information is also in the Nearpod provided in Canvas. All right, and it is the periodic table Nearpod, and the code is there in your Canvas. Next, we're going to add at the top about your groups. So we're going to put a box, and we're going to put an arrow showing that in our groups, the same number of valence electrons are going down the column. So whatever group you're in, remember the valence electrons are going to be the same for that entire group. And we're going to add that to our periodic table as well. And last, what we're going to add to our periodic table is reactivity again. As you go from right to left, your reactivity is going to increase. So you're going to draw a line on your periodic table down here, and you're going to write increasing reactivity. Because like we said, group 18 is going to be, they're going to have a full valence electron shell, or the valence electrons are going to be full because the max is 8 and they have 8. So they're happy. So it's not really reactive, but the closer we get to 1, the more reactive it is. All right? So now when we move on, we're going to talk about what makes a particular atom happy. So when you draw those Bohr models and you're looking at that particular atom, what makes it happy? So we've already said having its outer energy level filled makes it happy. And it has to have 8 to be filled. So that's what makes it happy. So if you look here, this whole group 18 has been highlighted in red to let you know all of those elements are happy. They're stable. They're inert. So when you see the word inert, they're stable. They're happy because they have 8 valence electrons. They're full. All right? The same thing. The atoms do not want to bond with anything else because they're already full. I don't need anything else to be full. I already have 8. That's the same way if you're hungry. you want to eat so much, so you want to move around and you want to try to find food. Whereas if you're full, you're fine. You want to sit down, relax, maybe even go to sleep. So that's what's happening here. They're full. They don't want to bond with anything else. And the reason is because of the octet rule. So if you take a look at the octet rule refers to the tendency of atoms to prefer to have 8 electrons in its valence shell, which is that last shell. When atoms have fewer than 8 electrons, they tend to react and form more stable compounds. So anything closer to 1, they're not full and they're trying to become full. So they're going to combine, or they're going to bond with other elements in order to have a full shell or a full energy level of 8. And we're going to get into that next week on how different elements bond with each other to create different chemical reactions, or different chemical formulas, or different types of chemicals. So that's what we talked about today in class. If you guys have any questions, feel free to message me in Canvas. But pretty much, make sure you annotate on your periodic table what groups are, what periods are, what they're used for, what makes an atom happy. I'll see you next class.